YouTube people. In this video, I kind of wanted to review the difference between an entry-level plasma table, what to look for, and a little bit more higher-end plasma table. When I bought my first table 3 years ago, I couldn't find a video kind of telling you what to look for. I wanted to do the video before I sold this plasma table, but it sold too fast. So this is my entry-level table. I already kind of started disassembling it to get it ready for the guy to pick it up. You have, it's a grid system slats, and they're about 16 gauge, 14 gauge slats. And I also have the slats for the waterbed. My MaverickCNC, you have about 1/8 inch flat bar. This flat bar sits in a groove on some 1/4 inch plate, which is nice because it's easy to change. You could even just go over and order a bunch of this flat bar at a specific length. And it doesn't have a tendency to bow because you got a center support in the middle. Over here on this other CNC machine, you got these big voids, and the 16 gauge, after so many uses, starts to get a little bit of a bow in the middle. And if you know anything about how these run, this one uses Mach 3 as your driver system. You have a torch height minimum, which is there's a maximum and a minimum. So it's not going to go below that minimum. So let's say you started your pierce right here. It's not going to go below that, from what I understand, because I've had issues with this. So if it bows in the middle, your torch height distance is going to start increasing, which isn't good for consumables, and consumables aren't cheap. You can see I've gone through quite a bit, kind of just scattered around. But in this entry-level table, it is a bolt-together kit. So everything on this is I put together. It was all bolted together in the gantry, and you periodically have to square it up because it can come off. There's only 2 bolts holding this side and 2 bolts on that side holding the gantry square. All right. Now, if you're starting to do some lighter gauge material, you got to move faster. And what happens when you move faster? The whole table kind of moves. So you can't quite go as fast, which puts more heat into your material. Another thing about bolt together kits, this did not come with these pans. These pans I built and I made them into a drop-in system, which I probably should have just gone with a waterbed because I never got around to doing a downdraft for this. Walking over to the Maverick, it has a waterbed as well as a downdraft. So this is about a 10-inch deep pool. And in the middle, you have a bolt together flange that you can flip, and you gain a downdraft system. Let's say if you're doing HVAC and you need something more efficient, don't want to get everything wet, and you have this flange in the back that you're going to run all your ducting to pull all your exhaust out, which is nice. This table came fully assembled, other than minor things like the torch and very minimal things, but it is rigid. This entire thing is one unit. I bolted it down, lagged it to the ground, made my own shims, leveled it, and this thing is solid. There's no give in this machine. To the gantry. This gantry is a billet aluminum gantry. I'm not quite sure what's all going on under the case when it comes to how it's all assembled, but it is really rigid. You look at your torch height, controller, and head assembly, you have some pretty thick material. It's like 3/8 to 1/2 inch steel or aluminum plate. Very rigid, no give. About the torch height controller, you have a couple different methods. You have ohmic sensing, and then you have a limit switch. In this machine, I didn't have ohmic sensing, it was a limit switch, so it would touch off your material and then come back off, and that's what would set it. The limit switch on this one is prone to corroding if you're running a water table. This one runs on a screw. Back over to the MaverickCNC. So I keep saying torch height controller, which is not quite the torch height controller. This is more telling it the height of the steel. So in this one you have a limit switch as well as ohmic sensing. So if you're to do the limit switch, it's going to put a load on your steel until the limit switch comes off and then come up. So if you have light gauge steel, it's going to put a little bit of deflection in it and then come back up. And now with the ohmic sensing, I'm going to show you. That's it. Sensed the metal, went back up, and now it knows the height of the steel. Next on the list is what is the gantry riding on? So right here we have a gear drive. We have where the rollers ride on, and these are replaceable. They're bolted on, and say you dinged it, I'm sure you could just order a new one with these preset holes and bolt a new one on and send you back on your way. There's your V-roller wheel, as well as the gear drive down in there, which runs on a larger motor with a gear reducer, and it's belt driven. Less load on your motor because it's using more torque, longer life on your motors. Come over to this CNC table. It runs on a gear drive just like that one, but these are welded on. Another issue is these are very exposed. This is mounted on the side, whereas the one over there is loaded on the bottom. So let's say I'm loading some steel and I whack it right here. Put a giant nick in it. I'll always have a nick in that unless I cut that off or replace this entire rail. And I don't know about you, but I'm kind of clumsy. So coming through here with some 1/2-inch steel or some 1/4-inch steel, even just not paying attention, I'm sure I've been very nervous about that. That was one thing I really didn't like about this table. But when looking at your rails, my rails sit a good six inches higher than my cutting deck. This one, they're below it, they're tucked out of the way, and I'm not worried about hitting it. I can bring a sheet of metal over to the side of it, tip it over, lay it down in there, no problems. Now on to the waterbed. This waterbed is all integrated into the table. If I wanted to do a waterbed on this one, I would have to have, it's a bolt together pan system. And there'd be 4 sections on it. And you gotta RTV them and hope you don't leak. And they were probably like 16 gauge, 18 gauge stainless steel. And I'm sure that they'd be prone to warping a little bit and just not the best. But this is an entry-level table. Kind of going back to the frame setup on this table, it's not even bolted to the ground. I actually took these off of a fume hood stand, and there's a 1-inch threaded foot on it so I can adjust my height, and I used a laser to get this all plumb. And even then, let's say you get the rails plumb, but the slotted holes have a 1/16 out, and your deck is out a little bit. There's just too much room for error when bolting these together. Whereas this one came with threaded feet so I can adjust the height all in one, which was very convenient. Didn't have to lift it up and mess around with it. Just took a wrench, did some minor adjustments here and there, and it was level. The torch height controller. So this is the actual torch height controller. What it's doing is it's actually taking readings off the actual torch as it's cutting, and it's a voltage divider, so it's cutting it in half. And this runs on 110, and I preset it for my hypertherm settings, and I just haven't had the best luck with it. It works, it's just not quite that efficient. This machine, it's all integrated. It's all in the box. Everything, it's supposedly checking 1,000 times a minute is what they told me, and yeah, it's awesome. So I got, it would be right here, your sampling, and that's going to be giving you your voltage divider set at 126, and that was for this 3/16 plate, and it's just constantly monitoring it, and I'm watching it, and it's maintaining the cut gap just fine. On to the software. So with this machine, you get 4 sets of software. You got your Mach 3 loader, which is going to be what you're going to be using to cut everything with. That's when you're going to hit start. You're going to be loading your G code into this stuff. You got your Inkscape, which is kind of reminds me of like art or paint, where you can color, you can take drawings, you can take images off the internet and run a path on them. You have your QCAD. So this is the one that you're going to be doing all your drawings. Like let's say you wanted to do a 4-bolt flange. You go over here, set that up, click it, and then you can type in your coordinates. Let's say I wanted a 4" by 4" flange. We're zooming in. We want to put bolt holes. I'm no expert. All this has just been learning as I go. So I want to put 1/4" offset with some 1/4" holes. And that is how this system works. And you get better with it as you go. You can chamfer your corners. Let's do a 0.25. So you get the picture. And then you got to go back in, delete your lines, your reference points, this, that, and another. So then you would file, save this as a DXF file. And then you take that DXF file and then you go into sheet cam. This is where you're going to file, let's say you want to import a drawing that you just drew. Let's do a window well. Bottom left corner, 1 inch. There's my window well that I designed. And then you're going to go over here and pick your tool, which you're going to preset all these tools for each one. I got 1/2 inch, 3/8. This is for my 45 amp hypertherm that I'm running. And then you're going to set your inside offset, layer 0, and your outside offset, layer O. You got your inches per minute, arc, set OK. Runs your cut path, and now you're going to file, run post processor, and save this as a G code. G code is what you're going to be cutting over here in Mach 3. Actually, I already have it up. This is where you're going to load your G code. So you got all this code. So you bring it in, leave window, loads up. There it is. So now you need to zero the machine. This machine does not have end stop, so if you go too far, it'll come off the track. It'll come off the track on the gantry. You need to set your reference point. So let's say I had a sheet of metal there. You would want us to zero it. Boom, boom, boom. Now you're zeroed. You can kind of see where it's at. But if you want to zoom in, let's say you wanted to zoom in on this. I never got good with this. I could never figure out too well on managing this. If you click on it, it starts doing some weird stuff. So I'm no professional. I have learned this table using YouTube and asking people, because this company was next to non-existent when it comes to phone calls, emails, or anything. I could not get a hold of them. They would not email me back. It was very frustrating. Come to find out, I don't know if it was due to COVID or what, but they are no longer manufacturing tables. So whatever that's about, there was some talk of other stuff that I'm not going to get into. You got your torch height controller and you'd hit start. I've had issues where if I press pause or stop and then try to start up again, you can't jump to a different cut line. You have to find a new drawing and kind of readjust it or jump around. I'm just not that great in this, but I've hit stop and then I hit start and all the motors started running backwards. So anytime I press pause, I close my entire file and I lose that material. Over to MaverickCNC software. I'm not sure the specifications of this software, but this one says MaverickCNC, so that's what I call it. So this is what came with the machine. Let's say I wanted to make a 4-bolt flange. You got your 4-bolt flange, and it pretty much has a whole build kit. You want your width 4 inch, height 4 inch, diameter of your hole 0.25, offset 20 quarter inch. No, it's not quarter inch. And then you're gonna go over and you got to fill it, or you can do a chamfer, or you can do a straight. And you can choose the radius of it and then press your check mark. There it is. So now you take it. I've only had this machine for 2 weeks. The computer is just a little bit slow, but software has been super easy to learn. You got grouping, ungrouping, explode, a lot of the similar stuff. Super easy to take a picture from the internet, load it in here. So now I'm going to shoot it over to cam. It just set my cut path, and it's like, I don't want that there. I'm going to take it over here. Right click, I can move stuff around. And now I want to take this to the bottom of my sheet. And then you go over here. You're like, okay, Power Max 85. My sheet's 120 inches by 48. I'm going to be cutting out a 3/16 steel. Mild steel, check. Everything looks good. I'm going to go over to my tool. Power Max 85. For some reason it's not loading. Last fabbed parameters lookup was successful. There it is. Okay. So now here's where you're going to pick your consumables. You run an 85 amp shielded, 65 amp shielded, 45 fine cut. So right now 65 amps, plenty. Air, best quality, feed rate, preloaded, kerf width, pierce height. These are all of Hypertherm's preset settings, and they work great. On my holes, I reduce it. Any hole that's less than 3 times the material thickness, I reduce the feed rate down to half to get optimal holes. You hit check. You're going to move this over to your CNC, your cutting file. So this is where you're cutting at. So let's say that's there. I want to home my machine. This machine's going to know exactly where it's at after I home it. Go over here, put home all. It's going to go and find itself. It goes slow so it doesn't crash, and it's using those little plates right there, and it's using a proximity sensor to tell when it finds it. And there's on the gantry, there's a proximity sensor as well. Find itself, and now it knows where it's at. And now I have a park setting, and I even have a front park setting. But let's say I want to take this machine over here. I wanted to cut it right there. I would zero my X and Y axis. So my program is zeroed there, and my machine is zeroed there. And I even like to make sure it does the ohmic sensing, knows where it's at, and then I can just hit play, and it's good to rock and roll. You also have extra settings over here, where if you want to adjust your feed rate on the fly, your cut height, your safe height, which I really like. That's when you have, let's say you have something with a lot of tip-ups, like this one. I crashed yesterday because I had a tip-up and it hit it, and my tip-up height was at 1/4 inch. So that's when it comes up and it travels. That's what height it's going to travel at. I raised it to 1/2 inch, gave myself a little bit extra clearance so it can try and dodge tip-ups. So that's a really nice option that I like. Things to go over on this is here's your torch height controller on off, your auto sampling, which is taking samples of it, and back to cam you have nesting, which is very valuable. So let's say you had multiple parts, it would give you document 1, 2, 3, 4, 5, 6, etc., and you can go through them and say I want like 6 of these, and then or fill the sheet, or even fill extra sheets. It'll give you more cut sheets. Nest the corner from which side. We're coming from the south side, as well as how far apart do you want each part, rotation, steps, geometry, etc. Start nesting. Now I got 6 of them. And you just hit the check mark. But you can fill it. You could load a whole bunch of different files in here and pick of how many you want of each, how many is your job going for. Very simple. Whereas in SheetCam, you have nesting capabilities, but it's not to this extent. It would just be one part, from what I understand. I am not an expert in SheetCam, so I'm sure there's more to it than what I know, but I've had a hard time learning all the different aspects to it. So I usually just array how many parts I need, which would be like this. This is called grid nesting, but when you do an array, it's similar to this right here, but you can't import more than one part. I don't know, it's just hard to explain, a little bit difficult. Buying a plasma table, you're going to want to have a resource if you have issues. Dealing with Maverick, I sent them an email and I swear they call me within like 2 minutes. They're like, here's your issue, here's a fix, or here's a lead time, this, that, another. Oh, you need some consumables. They're like my one-stop shop. They're very easy. The lady at the front desk, super nice. The technician came out for 2 days, super great guy, super quick, super knowledgeable, and that was included in the sale price. This machine over here, the training was YouTube videos that they uploaded. Zero contact with the people. So you had issues, you surfed through their YouTube, and they even had a file of known issues. It's bad when they have a file that says known issues, but makes sense because I had those issues. And there was things like changing my motor direction and stuff like that. All in all, for the price of this machine, I got it. Not gonna say the price, I guess. Entry level, you're looking at $5,000 to $7,500 for just the table, not your cutter. It was a great machine. It made its money's worth. It worked, made it work. Did I turn down jobs because I didn't trust this table? Yes. Do I want to load 1/2 inch steel on this table? No. I don't really have it situated to where I can load it easy. This table, do I feel confident bidding jobs? Yes, I do. I've had the machine 2 weeks and I've already made a pretty good amount of money on it, just off of a couple different jobs. This last 2-day job, it only took a day, but didn't have much going on, so I spanned it out to a couple days. But I like something reliable, something I could trust. You shouldn't be worrying about your machine. You should be worrying about other things. This should be the least of your worries. When you hit play, you want it to do what you paid for it to do. Sure, there's a lot of things I'm missing, but things like dust accumulation, maintenance. These motors are 1-to-1, whereas that one's got gear reducers, so it's putting less load on the motor. These motors get quite hot. This does use kind of like a standard, kind of like a skateboard bearing. You kind of assemble it yourself and try to get it as tight as possible. The tables are all honestly kind of similar in what they do and how they work. you're just getting better software. The more you pay, better software, more rigid frame, ease of use goes up, and reliability. This table, I can pick it up with my forklift if I need to move it. Very simple. I can contact the vendor just about any hour of the day, and they will be more than willing to help. They're going to be in business for a very long time. They've been in business for a really long time, and the cut quality has been great. But you pay what you get for. This machine, you're sitting between 30 grand up to 40 grand at whatever price they have them listed for. And this was back last year when I bought it. It took about 4 weeks to ship out, and on the freight truck when it showed up, this wasn't the only one on there, which is kind of reassuring knowing that more than one person's buying it. This machine, I ordered it in July of 2017 or 18, and I didn't see it for 6 months. So that kind of sucked. But it was a cheaper table. It was a smaller business. It's kind of a mom and pop shop. And the machine honestly does what it's intended to do. It's just not as, it's more, I call this machine the hobbyist machine. And I call this a production machine. This is something you can write all your files in the morning, come out here, and they'll be preloaded on sheets. You can run HVAC software on this. There's just endless capabilities. You have attachments for this. You can have engravers. You can have a torch, like a oxyacetylene torch. You can have an angle bevel cut attachment for this. You can attach a laser to this. They have all those attachments and many more. They have higher end tables. So this table is getting built in the same place as $100,000 water jets, laser cutters, and their high-end true hole guarantee plasma tables. And those are up in hundreds of thousands from what I understand. So this is getting built in that same place with the same technology, which is nice. Just to sum up this video, I wanted to do a video that kind of just goes over bottom line, cheapest table you could find on the market, because it was. That my first table was the cheapest 5x10 table I could find on the market. And it worked. I'm not making a video to badmouth that company. Having a company is tough. Like, they probably sold more than they were thinking, and they probably got a little over their head. I don't know. But I wanted to do a video because I was kind of looking for a video on what to look for when buying a CNC table. I didn't go over everything. I'm not an expert in it. I know some things, and I kind of went over the things that bothered me about the one and the pros about the other. I've only owned the Maverick for 2 weeks now, and so far I love it. But who knows, maybe in a couple months I'll be banging my head against the wall like I was with the last machine. But for right now, I like it. I'm not paid by Machitech or MaverickCNC to make this video. I just did it because I feel that it's beneficial for other people in the market for a CNC table, because not everybody's experienced with them, and my experience was minimum. My experience was high school, 3 years in high school. I worked at a fab shop that had one, never really played on it, so my experience with them was pretty minimal. The Waterbed, I like it a lot for just a small shop. It keeps my fumes down. If you look at my garage door, it is black. It is covered black. My walls are black. Everything's black in my shop from not having the right fume control. But back to the topic. Just kind of want to do a video on what you're going to get. And hopefully it was informative and you got what you needed out of it. I'm not an actor, I'm not a video photographer, I'm doing this on my cell phone, so it's not perfect, but I did it for you, so I hope you liked it.